What if the universe looks like a giant brain? That simple question grabs you. It feels bold. It feels like a thought experiment you can see. Imagine a brain scan morphing into a JWST deep field of galaxies. Think of a dendrite folding into a filament. In 2025 we had fresh sparks that feed that image. OSIRIS-REx returned organics from Bennu. JWST kept finding early galaxies. The timing matters. New images sharpen old metaphors. New molecules nudge old questions. Dark energy debates in 2025 added more heat. People asked if cosmic structure and cognition share rules. This essay rides that curiosity. It keeps language plain, tone, upbeat, slightly dramatic. I will show simple visuals in words. Expect brain scans. Expect galaxy maps. Expect fractal art. I will define fractals simply. I will link to 2025 news items that matter. I will avoid heavy math. I will use clear examples anyone can picture. Snowflakes, river deltas, tree branches. They make fractals easy to see. This is not a claim that space thinks. This is not grand metaphysics dressed as evidence. This is a guided tour of pattern, data, and idea. We will compare shapes and numbers. We will point to theories without deep equations. We will end with a clear takeaway and an open question. Engage, wonder, comment. Yeah, let's go. Start with one word. Fractal. A fractal repeats a pattern at many sizes. Look at a snowflake, its arm. The arm echoes the whole snowflake. Look at a fern leaf. Small leaflets mirror the full frond. Fractals show up in math. Fractals show up in nature. Simple to imagine. Powerful to study. Fractals make messy things feel ordered. River deltas branch like tree limbs. Lightning forks in a fractal way. Cities grow with fractal street patterns. Even coastlines can be fractal. That repeating geometry helps us measure complexity. A single rule can produce infinite detail. The universe shows fractal hints too. Galaxies clump again at larger scales. The cosmic web has threads and knots that repeat. In 2025, new analysis pushed this idea back into view. Some parts of the dark energy debate asked if structure is truly smooth. Viral science posts amplified the fractal narrative. Sober science. Popular curiosity. Fractals also give us tools. They let us compress complexity into simple metrics. Fractal dimension is one such tool. It summarizes how patterns fill space as you zoom. Scientists use these tools across fields. Cosmologists, neuroscientists, different languages, same math. That's kind of neat. Fractal cosmology is a label for bold ideas. It asks if the universe is hierarchical instead of smooth. Think Russian dolls nested inside each other. Some models say matter organizes into nested patterns. These models challenge the view of a uniform cosmos. Chaotic inflation feeds the image. It pictures the early universe as a frothing field of bubbles. Each bubble can spawn structure at many scales. Those bubbles can create fractal-like distributions. The result is a cosmic landscape of nested patterns. Other approaches play with space itself. Causal dynamical triangulation imagines space built from tiny pieces. Non-commutative geometry changes how coordinates behave. Both can produce unexpected structure when scaled up. Alain Knes and others use this math to rethink space. These ideas are getting chatter in 2025, as data pushes back. The debates matter for dark energy. The debates matter for fate. In 2025, some researchers asked if dark energy is simple. Others suggested its effects might vary with structure. If the universe is fractal in some way, those fits change. That can alter interpretations of accelerating expansion. We must stay open and test ideas with data. Let's keep testing. The cosmic web is spectacular in images. Galaxies arrange along filaments, walls, huge voids sit between those structures. JWST finds surprisingly bright early galaxies that form knots. These knots sit at filament intersections. Simulations show matter streaming along filaments into clusters. The cosmic web is a natural place to spot fractal patterns. Filaments are like threads in a vast net. Nodes are dense clusters of galaxies. Voids are the empty bowls between them. When we map these features, patterns repeat at different scales. That repeatability echoes fractal ideas. It invites comparison with other networks, like brains, Vasa, Faletti, and others noted similarities. They compared metrics across cosmic and neural maps. Degree counts, clustering, filament lengths are measurable. Some numbers fall in similar ranges across scales. This is not proof of shared origin. It is a curiosity that invites cross-disciplinary study. We can also play with memory metaphors. Cosmic structure stores information in its arrangement. Galaxies remember past dynamics in their positions and motions. Some playful estimates compare petabytes of structure. Those analogies are evocative rather than definitive. They spark the imagination and new analysis. So, yeah, that's the starting point for the questions we'll keep asking. Brains are fractal painters too. Dendrites branch in repeating patterns. The arbor of a neuron looks similar across scales. Cortical folding follows fractal laws in many species. These shapes help pack computation into limited space. Fractal branching maximizes contact and minimizes wiring. We can measure fractal dimension in brain tissue. Healthy brains show characteristic values. Disease can shift those measures. In 2025, researchers used fractal biomarkers for early detection. AI pipelines accelerate pattern detection in clinical data. Fractals help translate messy scans into meaningful numbers. Neuralink and similar tech make these links practical. Interfaces read signals from fractal networks of electrodes. Understanding network geometry helps engineering. Better models inform implant placement and decoding. Fractal insight can improve signal interpretation. That aids therapy and brain-machine interfaces. The medical implications are real and near-term. Diagnostics benefit from pattern metrics. Therapy design can use network maps. Rehabilitation can track structural fractal recovery. Fractals are not magical cures. They are practical tools that sharpen clinical vision, you know. Now compare wiring and nodes. A human brain has around 86 billion neurons. Each neuron links to thousands of others. That gives rise to trillions of synapses. Network hubs coordinate global activity. Memory emerges from patterns across those links. Numbers here are large and, vivid. The cosmic web has nodes too. Galaxy clusters are the nodes. Filaments provide the links. The scales differ by unimaginable factors, yet both systems show hubs and peripheries. Both support flows. Electrical in brains, matter in the cosmos, and light in the cosmos. Both maintain structure across time. Memory capacity comparisons are playful. The brain's storage is often quoted as 2.5 petabytes. The cosmic web's structural information can be estimated in similar units for thought experiments. These comparisons help people picture scale. They are not claims of identical function. They do, however, urge us to think about information across domains. The panpsychism debate grows in this space. If systems process information, does that imply proto-experience? Some philosophers say maybe. Most scientists say not, without far stronger evidence. The conversation is useful because it forces clarity about what mind and information mean. It also highlights how metaphors can both illuminate and mislead. We can list clear metrics that map across systems. Degree centrality counts how many links touch a node. Clustering coefficient measures tight local groups. Power spectra show how variance depends on scale. Fractal dimension captures how pattern fills space. These measures are computable for both brain data and cosmic maps. Vaza and Folletti highlighted parallel ranges. They showed that despite size differences, some statistical fingerprints align. This alignment came from simulations and observations. It does not mean the same cause drives both patterns. It does mean similar generative rules can produce similar outcomes. Why might that be? Think growth rules. Systems that grow by attracting more links often become scale-free. Preferential attachment produces hubs and filaments. Branching produces hubs and filaments. Self-organization with feedback yields fractal layouts. That general logic applies to fungal networks, cities, brains, and cosmos. Common rules produce common shapes. These parallels give practical pathways. Cross-training methods can move between fields. Network analysis tools can jump from MRI data to galaxy surveys. Shared metrics improve communication. They also help spot where analogies break down. Knowing the limits keeps science honest. This topic touches big questions: panpsychism, interdisciplinary AI, medicine. If pattern is key, then tools from one field help another. AI trained on neural graphs may suggest new cosmic analysis pipelines. Medical fractal biomarkers may borrow cosmology software. The cross-pollination is exciting and practical. Dark energy debates could shift. If structure matters in unexpected ways, expansion fits might change. 2025 discussions about dark energy variance reflect that possibility. We must test these ideas rigorously. On the medical side, better pattern detection could save lives. Early signs of dementia might be visible in fractal metrics. AI could monitor and assist. Implants like Neuralink could monitor and assist. Ethical and practical questions follow. We must balance innovation with caution and patient safety. For AI, nature remains the best lab. Studying efficient natural wiring can inspire new architectures. Fractal branching, hub organization offer design principles. These ideas could make AI more scalable and robust in labs, hospitals, observatories. Here is the clear takeaway. Patterns repeat across scale. Fractals. Network math lets us compare brain and cosmos. 2025 data sharpened the conversation. Osiris, Rex, JWST, new dark energy debates give the idea teeth, but similarity of shape is not proof of shared purpose. Use the tools, stay skeptical, measure, model, test, let metaphors guide experiments but not replace them. Encourage cross-disciplinary work, share data, share methods. The image of a cosmic brain is powerful. It fuels curiosity and new research paths. It helps clinicians, cosmologists, engineers talk. It also warns us about overreach. Beauty alone is not evidence. So I'll end with a question for you. Do you think shared pattern rules hint at deeper links? Or is this resemblance just nature reusing efficient designs? Share your thought. Let the conversation grow. What if the universe looks like a giant brain? Hit like and subscribe for more science adventures. Stay curious.